things that are already on the whiteboard will disappear, but fine. Let's carry on. Let's carry on. Okay. So, okay, let's start by reading through the problem. We're doing problem 81, right? The blocks shown in figure are at rest. Okay. Find the frictional force exerted on block A given that the mass of block A is 8.82 kilograms. The mass of block B is 2.33 kilograms and the coefficient of static friction between block A and the surface on which it rests is 0.320. So this thing is like this. They say we must find the frictional force. I've already drawn this. So let's go and find that frictional force. Okay. First, we're going to write Newton's second law for block A and for block B and for this what is this? The knot right here. Okay. So let us do that. Let us do that. I'm going to start with block A. Okay. So as we can see, the forces are along the x-axis. So let's start here. Sum of the forces in the x for block A are equal to, okay, the one that is facing the left, which is the frictional force, will be negative. Okay. And the one that is facing the right, which is the tension, TA, will be positive. And they must give us 0. Okay. Now let's write Newton's second law for block B. Let's go. Let's say sum of the forces in the Y for B. Okay, in the X. Let's say in the X, because we said we're going to let the right direction be positive and the down be positive X. So let's do that. Yes. Okay. So we know that the weight is mg. Again. Okay. So we said we're going to let the downward direction to be positive, meaning that the upward will be negative. So negative TB. We are adding the forces plus positive mg. Which m? The ones that has got to do with B. These forces must also give us 0. Now, for this one, for T3, we can see that it's not horizontal or vertical, but it is sideways, meaning that it has a horizontal component and a vertical component. So what we need to do is to break it down to its components. We can't just take it like it is. Okay, and the angle here is 45 degrees. Okay, we're given. Okay, so let's write it. Let's start with the x component. Okay, the x component, let's say sum of the forces in the x for the knot. Let's just write k. This is becoming nasty. Is equal to, okay, we have a force here that is going this way, which is the x component, and because it's in equilibrium, we said this thing, there's another force that is pulling that way, which is this one, the tension here. So T1, if you look at it from T3's perspective, T1 is pulling that way, TA. So we have TA being negative, the negative force. Okay, plus. Now the component here, the horizontal has got to do with cosine, né? So it's T3 cos theta. That will give us the x component. And theta is 45, so we can just write 45 degrees. And this will equal 0. Right, now let's write the other component, the y component. Okay, sum of the forces in the y direction for the knot is equal to, excuse me, we said this is positive, we're going to let that be negative. Okay, so okay, no, this one is for this one. Now we're at this one. So for the forces that are like this, for this one, the component that is pulling up is what? Is got to do with T3 sine theta. The one that is pulling down, okay, we are focusing on this thing right here. The one that is pulling down is TB, this one. So let TB be negative, because it is pulling down. Remember, we are no longer focusing on this right here. We are focusing on this right here. So we're going to say plus T3 sine theta. And also they will give us 0. Okay, now what? Let's divide the y equation for the knot by the x equation, ne? If we divide the y equation for the knot by the x equation, we're going to find this. Akira, we said minus TB plus T3 sine 40 degrees is equal to 0. So what we can do is to take the TB to the other side, and we'll be left with T3 sine theta sine 45 is equal to positive TB. We're dividing by the x. So we're taking this one, dividing by this one. Okay. That one will give us T3 cosine theta. That's if we take the negative TA to the other side. Cosine theta, which is 45. And it will give us positive T. Okay. T3 will cancel T3. But now sine 45 over cosine 45 will give us tangent 45. Tangent 45 degrees. It's still equal TB over TA. But we know that tangent 45 is equals to 1. So this means that 1 is equals to TB over TA. We can now cross multiply. We find that TB and TA are equal. Okay. Let's say TA is equal to TB. Okay. Now that we know that, excuse me, TA is equal to TB, right? Let us substitute that into TA is equals to, let us substitute that into the equation from step 2. Let's do that. So let us substitute it here. Ne? Let me see. TA is equals to what? Two is equals to mg. I need a lot of space now. Let me move this thing up there. Okay. So now, since I know that TA can be substituted into TB, which one am I gonna choose and substitute it here? Okay, I'm going to take TA and substitute it here in the space of TB. So when I do that, I find that TA is equal to M MPG, because I took TA and I put it here in the space of TB, and I took the negative the positive MBG to the other side. It became negative, so that means the negatives, they cancel out and this becomes just positive. TA equals to MBG. Okay, let's continue. And then let's substitute this into step 1. Okay, let's substitute this into step 1. This means that negative is equal to negative TA. This means that the negatives can cancel themselves, and what we can now do is to say, we know that TA is equal to MPG, so where there's TA, we're going to put MBG. So M is what is 8. M for B, this one is 2.33. Times G, which is 9.81. And this tells us that our static friction is 23 newtons. Okay, that was very long. But yes, finally we found the static friction. B, if the mass of block A is doubled, does the frictional force exerted on it increase, decrease, or stays the same? Explain. Yeah, the frictional force will not be affected by the change in mass. Okay, so it will stay. It will stay the same. Okay, it will stay the same. It will not be affected by the change in mass. Okay, if they give you this question in an exam, Ishail, it's school out. I don't think they would do this to you guys. This is just for torturing you during your assignment so you can do more research. But yeah, okay, let's continue. What is the next problem? Okay, the next problem is 99. It's this one right here. Okay. A mountain climber of mass M hangs on to a rope to keep from sliding down. He hangs on. Okay, that means he's not sliding down. So I'm sure you know, Uguti, that means there's equilibrium involved. Okay. Ice covered slope. From sliding down a smooth ice covered slope. Find a formula for the tension in the rope when the slope is inclined at an angle theta above the horizontal. Check your results in the limits theta is equal to 0 and theta is equal to 90 degrees. Okay. So what is the strategy? Let me first draw this climber so that we can make our own lives very easy. Okay, I'm going to draw him here. Okay, so he's hanging on to a rope. Let's say this is the climber. It looks like a box. He's hanging on to a rope. Okay, so we can see this is an inclined problem. We have theta here. And what did I say about the inclined problem? The inclined problem says this is mg sine theta. Mg sine theta. Okay. What else? What else? Yeah. Okay, so that would be the weight. Okay. All right, so this ice-covered slope provides no friction, right? Yeah, ice-covered slopes provide no friction. So now we know that they said we must check our limits here. Theta is equal to 0 and theta is equals to 90 degrees. But now if we say theta is equals to 0, this means this person is not hanging on to anything. He's lying on a flat surface, which would be wrong in this case because they're saying he's hanging onto something, right? So this means that we must check in the limits of theta is equals to 90 degrees because that would mean that he is hanging onto something. There's an angle there. Okay. Okay, so let's write Newton's second law for this person right here in the x direction. So this is the x direction according to the inclined or inclination. This is the x. And this right here would be the y. This is the y direction. So, okay, let's do this. We know that there's tension T, and this tension is in equilibrium with the mg sine theta. Okay, so let's say the sum of the forces in the x are equal to 0. That means they are in equilibrium. Okay, and then we are going to take the direction to the right as positive and the direction to the left as negative. Okay, so this means that tension is positive and mg sine theta is negative. Okay, mg sine theta is negative, and we say they will equal 0. So if we take negative mg sine theta to the other side, it will become positive mg sine theta. Okay, but now we said theta is 90 degrees, not 0. Let's put 90 degrees there. But now wait, sine 90 degrees is equal to 1. So what does that mean? This means that T is equal to mg. Okay, so that would be the end of it. Okay. Yeah. Yes. We're done. Let's see if there's a follow-up question. Okay, so we are done with 99. But now we are going for which one? We have 8 minutes remaining. Let's see which one we are going to do now. For 8 minutes. Okay. All right. Let's do this one. Problem 107. The thing about problem 107 is I think it's gonna need more than 8 minutes. So what can we do? Maybe we can do problem 8 from yeah, we can do problem 8. Yes, problem 8 from okay. Let's do problem 8 from the next chapter. It's gonna be difficult getting there. Let's see. This is no. Is it this one? No. Problem 8 from this chapter. Sky, no. Where is 8? 8. You pick up a can of paint from the ground. Okay. You pick up a 3.4 kilogram can of paint from the ground and lift it to a height of 1.8 meters. How much work do you do on the can of paint? Okay. So we know that work is equal to what? FD. F being the force. But F can be found by MA. So let's write MA. A is the acceleration. But in this case, we are doing upward movements. We are lifting something off the ground. So that means we have to use the gravitational acceleration. Now we are given all of these things, so we can find this. We can even write h here because we are talking about height. So we are talking about vertical distance. They gave us 3.4 as our m, the mass. G is 9.81, we know. The height that we lifted is 1.8 meters. And what we get is 60 joules of work. That's how much work we did. Let's see. B, you hold the can stationary for half a minute, waiting for a friend on a ladder to take it. How much work do you do during this time? There's no movement, there's no force there. Everything is balanced when you're holding it like that. So the work done there is 0. No need for calculations, right? The work done for B is just 0. Okay. 2 minutes remaining. No, level, we did not get negative J, negative 60. That was positive for A and 0 for B. Now we are coming for C. C says your friend decides against the paint, so you lower it back to the ground. How much work do you do on the can as you lower it? Okay. So this is something you need to know. When you lifting something up, gravity actually no, gravity is supposed to be opposite. Let me not lie to you. Okay, let me remember. Okay, so it's fine. Negative work because You lifted something from the ground, you did positive work. When you get it back to the ground, you do negative work. Hence, for C, you are going to do negative work. Negative work. Negative MGD. So you substitute the same values, but you're going to get negative 60. Okay, we are left with less than a minute. I hope you get it. Lifting this up, positive work. If you reverse the work, that's negative work. Okay. Oh, okay. She said, okay, I saw on physics 1507 assignment. Okay. Yeah. Yes, there's one for negative and the other one is